So welcome everyone to our panel on research opportunities with OmniSOC and ResearchSOC data. My name is Ina Kouper. I'm the Director of Researcher Engagement for ResearchSOC. We have three great panelists with us today who will share their experiences either working with the OmniSOC and ResearchSOC data or discuss the broader issues of using operational data for research. So this is a brief overview of how our panel is going to go. I'll do some introduction to the ResearchSOC project. I'm sure you probably heard about it already, and the data aspect of it. And then the panelists will go into their presentations, about 10 minutes each. Then we'll go into the discussion for about 20 minutes, and that will wrap up around 2 p.m. But we also have a live demo that one of the panelists will show, and that will go for about 20 minutes, and then we'll wrap up at about 2:20, and there will be some break before going into the final remarks by Bon Welch. And I would like people to keep their questions towards the end into the discussion section of the panel. So now let me introduce our panelists. We have Dr. Jay Yang. He's a professor in computer engineering at Rochester Institute of Technology. His research focuses on advancing machine learning, modeling, and simulation for predictive cyber intelligence and anticipatory cyber defense. We have Dr. Sagar Samtani. He's an assistant professor in the Department of Operations and Decision Technologies at the Kelley School of Business here at Indiana University. And his research centers around explainable artificial intelligence for cybersecurity and cyber threat intelligence. And we have Dr. Anita Nikolic. She's the Director of Research and Technology Innovation and the Research Scientist at the University of Illinois at Urbana-Champaign. She served as a cybersecurity program director at the National Science Foundation and also has held a variety of research, security, and infrastructure roles in academia, industry, and government. So as I said, each of the panelists will talk for about 10 minutes after I'm done, and then we'll go into the discussion. So first, let me just say a few words about ResearchSOC and one of the objectives that focuses on data. You probably heard over the last couple of days quite a bit about both the OmniSOC and ResearchSOC and their goals of providing operational security services for higher education and science. But one of the objectives in ResearchSOC is to enable cybersecurity research. So that's our explicit objective since we're collecting all this operational data, and we are looking into how we can provide that for research purposes. And we're doing that through four interrelated activities. So first of all, we're trying to learn about researchers' needs for data and tools. We're also working on building a secure environment to access operational data. We're planning to curate and organize all those data, and we want to create awareness of the data and its potential. So this panel is actually one of the several events and studies that we're doing. So for activity number one, learning about the researcher's needs, I created some polls, and if you go to Whova, you will see those. Each poll is basically one question, and they pop up. And if you can answer them, we would really appreciate it, especially if you do research and you're interested in cybersecurity data. This will help us to learn about your current data practices and your needs in accessing that type of data. So this diagram illustrates our approach to building the Enclave, our goal number 2. From the bottom, you can see that logs and other security data that will be coming or are coming from ResearchSOC clients, they're going into this virtualized appliance, and then they're being ingested into OmniSOC. And so the researchers, if you can see at the top, they will be accessing the Enclave that we're building. That's also a virtual environment, and it has no internet access, so the data is stored securely there, and the analysis can be done only within that environment. And the results of the analysis will be reviewed by ResearchSOC curators and then released to the researcher. The elastic instance within that enclave that you can see on the diagram, this is where we house the data that's received from OmniSOC for analysis, and data can be queried either directly, or we'll also have a Kibana dashboard in the browser that allows you to query, visualize, and present data in different ways. So to access this enclave, researchers will fill out a data request and then sign an agreement. So this is the list of OmniSOC data that we plan to make available. Currently, we're focusing on Zeek data and Suricata event alerts. So Zeek data are logs from Zeek network security monitors. There are also some other types of data like IDS logs and events, traditional NetFlow data, and also Stinger. These are the logs from honeypots that are deployed using the project at Duke University. And these are examples of ResearchSOC data that we're also planning to make available. And as you can see, there are some overlaps between OmniSOC and ResearchSOC data. So here you also see Zeek data that we're providing, Stinger data, but also we're providing vulnerability scanning data that will be available. All right, so that's sort of a brief, very brief introduction of what we're doing with OmniSOC and ResearchSOC. And now, before we go into our panelist presentations and the discussion, if you're interested in talking more about your data needs and helping us and you to build the enclave and make this data available, we're interested in hearing from you, from all the researchers who are doing cybersecurity research and are interested in this type of data. So you can reach out directly to me. There's my email on the screen, or share your contacts by Hoover app or the messaging tools that are there. So now I would like to pass the screen sharing to our first panelist, Dr. Jay Yang. Jay?
Thank you, Ina.
Sharing.
Yep. Thank you. Thank you, Ina, for the introduction. And let me just move the screen so that I can see everyone. All right, thank you, Ina, for the introduction. Very glad to be on this panel with Sagar and Nina. I'm here to talk a little bit about our experience using Assert, which is a tool that we developed through a previous funded project by NSF, and developing and deploying that to use OmniSOC data, kind of the enclave situation that I was talking about earlier. This started around 2019 fall time to 2020 summer, a little bit into fall. And I want to appreciate that Ryan, Emily, Scott, and many other people from CACR and OmniSOC at IU to support all this deployment and discussion we have with them. Okay, so the problem that we try to tackle is really just too much data, too much logs, too many intrusion alerts. It's just not feasible for human beings to evaluate them in a timely manner, in a comprehensive manner. So what can we do? I mean, can we, instead of thinking about perceiving the alert, can we comprehend them better? Can we help the analysts anticipate based on some summary, right? So the current state of art, including Kibana and Splunk and other themes, that they're great. I mean, there's a lot of things out there, very good, providing a lot of data, querying, scripting, and other kind of capabilities. But at the end, vast majority of the SIEM capabilities is about presenting data, presenting these logs, these alerts in a summarized way, statistical way, but not putting them together in an intelligent manner. Right? So there are some here and there AI that can, so-called AI, to really correlate the alert, but still, by and large, most people are looking at querying alerts with specific IPs, that kind of thing, and volumes. So we ask ourselves, how can we use Assert, which is an algorithm that we developed over the past 4 or 5 years? How can we use that? And the algorithm is developed to really perform in a near real-time manner, right? It's not a supervised learning where you need to build a model and use a model. This is a continual learning system, unsupervised system that can generate, transform the infinitely streaming alerts into attack models. Each of these attack models represent unique attack behavior. And without expert knowledge, we're not requiring anything to be built ahead of time. And again, this is running near real time. So algorithm is great. Then we start developing prototypes. So we start engaging different SOCs. And fortunately, we got to talk to OmniSOC around 2019 summertime. They agree, and CACR OmniSOC agreed to have us work with them to use their data to record alerts in particular that and see what kind of attack model we can generate. So I mentioned about this notion of attack model. So most of you in the audience probably understand what IDS alert is, right? IDS alert typically give you source IP, destination IP, port numbers, some kind of signature describing what kind of activity was being observed, right? There will be a lot of false positive, a lot of false negative, that not either way. So here, we're not trying to replace IDS. Here, we're not trying to say, here is one indicator of compromise. What we want to do is presenting the characteristics of a bunch of alerts. They are not the same alerts. A bunch of alerts, they might be related. They're related, they can represent some kind of attack behavior. So what do I mean by attack behaviors? We're characterizing these attack behaviors based on, for example, how fast these attack actions are coming into the network. For example, what kind of attack stage? Think about kill chain. What kind of attack stage? Privilege escalation, data exfiltration. What kind of attack stage is going on with the behavior? What kind of combination that is? And also, what kind, is it like a inbound, outbound traffic? Is it persistent? Is it what kind of do they change the source IP to destination IP? What kind of behavior in terms of maneuvers in your network that happens, right? So there are things like this we can summarize, we can transform alerts into something that's easy, intuitive to understand. So let's look at some examples that we did by processing the OmniSOC IU data, disregard alerts. So I have a few examples here. First one, this is 2020, right? 2020, late July timeframe. We so just and then the demo we're going to have at 2 o'clock. We're going to dig in a lot deeper with a lot of different variety. These are just screenshots from the previous visualization we had. So late July, we transformed like almost 100,000 alerts per hour in that order of magnitude, maybe 20, sometimes 20,000, sometimes 50,000, sometimes 100,000, up to 100,000 alerts per hour kind of thing into about 20 attack models, and consistently 20 attack models. So the idea here is that bringing the analyst's attention to just a few models and see how they change, right? This is something certainly changed. So one of the attack model we saw last July, late July, is this arbitrary code execution through Kouper. Kouper is authentication protocol. And then this traffic is really inbound, persistent onto a particular destination IP. So we saw that. Okay, so we will say this is something that's not easy to see because there's only like about 300 alerts buried within that 100,000 plus alerts. Right? So if you were to really dig into the alerts, you will see them spreading out different places. You may not pay enough attention to unless you know what I'm looking for, you query exactly, or I'm looking at specific port numbers that's related to Kouper, right? If you don't, then you wouldn't get it. This will ultimately bring that to your attention, to the analyst's attention, okay? So this allows us to really see that. The other example is that, okay, we talked to OmniSOC analysts and to tell us or ask them what kind of attack, what kind of behavior that you're most interested. They say, let's look at command and control. So we try to search for command and control. So think about going back to the screen here. This is a screen. Each circle represents an attack model, right? You can have the axis, y-axis represent different characteristics. They say command and control. Okay, we look at one particular column that is command and control. What we found is a model that has continuous, almost periodic rising value on command and control through domain controllers, right? This is what I'm showing here is a timeline representing the volume over time on this particular model. This is a specific model. There's command and control and through domain control. It's outbound traffic. You can see that very interesting kind of periodically they're rising in volume. So of course, this could be, may not be necessarily malicious. It could be just some misconfiguration that leads to this periodical behavior. But it's very interesting that if you don't grab all this alert together, you wouldn't see this periodical behavior, and you wouldn't be able to understand that what might happen, whether it's malicious or non-malicious. Another disclaimer, because we share this with the practitioners on OmniSOC, and certainly we're not trying to ask them to confirm with us yes or no this malicious. So our model representing a behavior, but I'm not suggesting this must be a malicious. Okay, so that is around July 24th to August 4th. If I move forward a little bit in time, we continue to look for different command and control. It turns out there are multiple models, right? In here, I'm showing 5 different command and control models. The one I talk about, the domain controller, is the blue one. You can see the blue one go rising up and down, up and down. That periodic behavior continues to show up, right? At the same time, keep in mind that August 15, August 17, August, that time frame is the start of the IU semester, around that time. So one thing that we notice is orange one, the command and control going through MS SQL. So you can see the orange line here. There's a big rising. The y-axis is the volume of the alerts. You can see the rising from around very few all the way to several order of magnitude higher on the orange one, and they persist, continue after that for a few days. And this is just a snapshot of the data. So that's very interesting as well. It could be again due to that there's a new service being introduced because the semester are starting. It could be because just a volume of students trying to access something through MS SQL. We don't know for sure exactly what happened. It may probably, I would guess it's not necessarily malicious. It's just something that was introduced during the start of the semester. So this is another example showing you the value of the attack models. So we have, like I said, at 2 o'clock, we'll show you some other situation. We can do a live demo with you, and not live demo in the sense of the real life OmniSOC data at the moment, but previous data. But I want to summarize a little bit about the benefits of the service attack models and also the takeaways in this collaboration with OmniSOC and CACR. So in talking to the practitioners, analysts, we believe that it can provide a better and faster situation awareness. That is the idea of looking at 20 models, right? Roughly speaking, instead of 100,000 alerts every single hour keep coming in. And allow us to do that by focusing on more critical models, emerging behaviors, instead of sorting through all the alerts and do the query by analysts manually, right? And this is a near real-time intelligence driven by data in the network. It's not a threat intelligence that's reported every week or every month. It's really near real-time intelligence directly related to the data in your network. And we also track, like I show you, track reoccurring, the changing or emerging activity trends, which may not be easy to see if we don't have this model kind of scope on different behaviors happening on the network. We also see that it could identify some consistent events, which may be due to system configuration, not due to malicious activity, that we can fix. Finally, that we are working towards some kind of cross-organization benchmarking so we can help each other out in, say, Indiana University and RIT. IU sees this, RIT don't see that, and vice versa. What happened there? That will be a very interesting thing to do. Finally, the key takeaway is that this partnership allows us to see a lot of practical values of our system, but also see additional operational challenges which present new research problems. Thank you very much. And there is an executive report by Ryan that's accessible from his perspective, the benefit or usability of a CERT. Thank you. I'm going to yield, stop sharing.
Great, yeah. Thanks, Jay. So Sagar, if you can go ahead and start sharing your screen.
Okay. Can everybody see my screen? Ina, can you see my screen?
Yep.
Okay, excellent. Well, thank you so much for the opportunity to present on this panel. Really appreciate it. It's a tremendous honor to be speaking alongside distinguished scientists Jay and Nita. So my name is Sagar Samtani. I'm an assistant professor at the Indiana University at the Kelley School of Business. And Jay gave a great overview in terms of the potential of what can be done from the OmniSOC perspective and the types of data that's accessible through there. I'm going to focus a little bit more on the research SOC angle, and I'll give it from the perspective of AI for cybersecurity. And typically when I submit a lot of my work to conferences and journals, they ask me, are you playing buzzword bingo, attaching AI with cybersecurity and dark web and vulnerability assessment and so on. So hopefully throughout the course of the presentation, I can give you a little bit of an overview as to the unique positioning of research SOC and how it can actually help address many of the concerns within the prevailing AI for cybersecurity landscape. So first of all, how did I come upon this topic? I graduated with my doctorate from the University of Arizona Artificial Intelligence Lab under the direction of Dr. Chen there. I graduated in 2018. I was a National Science Foundation Scholarship for Service student. And there I really got the opportunity to hone in my interest and my experience in the areas of cyber threat intelligence, specifically identifying what kinds of threats and what kind of key hackers exist in the dark web and how do they relate with different organizations and so on. So I think that over time, the question that immediately started to rise is that how do you go about getting the data, analyzing the data, and so on. And so I turned a lot more towards artificial intelligence-based techniques such as deep learning, network science, and other methodologies to help sift through that data in a very efficient and effective manner. So a lot of my first body of work was focused on dark web analytics, emerging threats and exploits and so on. But increasingly, I got the question, how does that relate with an organization's vulnerabilities such that we can get a comprehensive overview in terms of what kinds of threats we should be prioritizing, what kinds of vulnerabilities we should be prioritizing and so on. So that was one of the things that brought me over to Indiana University, kind of the opportunity to be able to scale out some of my research at a larger scale and be able to interact with entities such as the OmniSOC, the ResearchSOC, and so on. And if we kind of give a little bit of an overview in terms of the ResearchSOC and the types of partners that they have, really what Ina had indicated in terms of the data that's being collected, I'll focus more on the vulnerability assessment side. But ResearchSOC is currently scanning major longstanding scientific cyber infrastructure such as NRAO, Gauge, Gemini, and so on. And there's a few key points I want to take away on this is that first, these entities have been around for decades, some of them going back to 1956. And so there's a broad range of technologies that they've developed over a period of time. And they're all doing really interesting work in different aspects of scientific research. And if we go ahead and map some of their scientific cyber infrastructure assets to key categories such as their instruments, the facilities, the hardware, and systems, we can get a really good sense in terms of has really unique sets of data compared to what you'd find in an enterprise IT environment, whether it be GitHub repository, specific types of instruments, signal processing, the types of data that will help scientists actually do their job. So the OpenVAS scans being able to do those types of vulnerability assessments on this unique breadth of scientific assets is actually quite unique from the ResearchSOC angle. But it's not without its challenges. We just kind of take a step back and take a look at what are some of the common challenges associated with vulnerability assessment. There are things such as data overload. I think that Jay had alluded to it in his presentation. The idea of prioritizing alerts, the idea of prioritizing vulnerabilities and so on is critically important. How do you go about doing that in an efficient and effective manner? Because sometimes the vulnerability reports that come back, maybe tens of thousands of vulnerabilities just in a single scan. So this is where something like AI for cyber comes into play. And it's been noted as a significant national priority by NSF, NSTC, National Academies of Sciences. And I just put some screenshots of some really interesting reports that have come out over the last year or two. And what I always teach in my class, I teach an AI for cybersecurity class here at IU, is the role of AI in the context of cybersecurity is twofold. First, it can automate a lot of procedures. It can sift through terabytes of data much more effectively than a human can, but it's also very powerful in terms of being able to identify patterns within large data sets that are not necessarily detectable through conventional manual analysis. If we take a step back and take a look at what the overall AI for cybersecurity landscape looks like as a whole, the major initiatives within this space and where ResearchSOC is uniquely positioned is that there are really four major categories of initiatives: cyber threat intelligence, disinformation, computational propaganda, more on the security operations side, and adversarial ML. And you can see some of the common tasks that are in there. There's of course going to be some overlap that's available within that context and so on. But if we really kind of look at what the key limitations within this existing landscape is that often there's a lot of siloed resources and initiatives, not due to anybody's fault. It's just sometimes the data sets that industry has may not be accessible to academics, and the techniques that academics are developing may not yield or be at the most realistic as possible. So things such as lack of publicly accessible data sets, realistic data sets is an issue. Model sharing and software sharing also remains a challenge as well. So if we kind of think about the positioning of ResearchSOC can really bring in that vulnerability assessment angle. And when you combine that with other data sets, such as dark web data, I'm using mine as an example, but if you kind of just think about the data sets that other researchers or other folks may have, you can actually start to ask some really interesting questions that are multimodal in nature, that are more holistic, that are not just looking at one aspect of data just by itself, but thinking about it in a more comprehensive fashion. So for example, if we just think about dark web analytics, look at the exploits that are out there, some of the potential value in the context of AI for cybersecurity on OmniSOC or ResearchSOC data is that how can the exploits from the dark web be linked to known vulnerabilities of devices that are in the context of ResearchSOC, OmniSOC, and so on? And then how can these devices be prioritized based on their vulnerabilities and the exploits that are targeting them? So we can get more comprehensive, holistic view. And really the initiatives that ResearchSOC is pushing in terms of the data enclave and having accessibility to data is very unique to facilitate some of these interesting research queries. So I'll just briefly go into some of the possibilities that are available within the context of ResearchSOC. I'm a very data-driven person. A lot of the work that I do is drawn from the data directly, but keeping in mind the domain importance and problems that are out there. So let's take, for example, the vulnerability assessment scans that exist out there and what kind of data they bring back. Typically, there's two major categories of data that's brought back from vulnerability assessment scans: description-based and risk-based. So if we think about the description-based, so to take the name, for example, there's a short descriptive title of what the vulnerability is. And that typically has a description in terms of the technology, the name, the system version, the operation that will be happening on there, and so on. And there's also lists of systems that are susceptible to the vulnerability, as well as a risk score associated with these vulnerabilities as well. And if we take a look at some dark web data in terms of what kinds of data characteristics exploits from the dark web possess, we can see that some of the key characteristics is that the tools from the dark web also have very descriptive tool names, very clear categories of exploits, the post date of when the exploit was posted, and so on. So being able to have access to both sets of data sources is very valuable from the perspective of being able to develop new techniques to automatically link what kinds of exploits on the dark web could be targeting specific vulnerabilities within the ResearchSOC or within other environments as well. So what could this lead to? Very high level model, but we can go ahead and develop novel models such as an attention-based deep structured semantic model. The idea of is if you know what vulnerabilities you have within an environment, how can you link exploits to those vulnerabilities? And you can also augment the model so you can make some more fundamental contributions to the AI space as well. So in this particular case, what we did is that we captured sequential dependencies within the names of the exploits and vulnerabilities, global relationships across both of the exploits and vulnerabilities, and also added in attention mechanisms to increase the interpretability of the results that come back. And this is the only math equation that I have, but the idea is we can also use the metadata associated with the exploits and the vulnerabilities such that we can devise new vulnerability severity scores, in this case, a device vulnerability severity metric, such that we can prioritize devices on a network a little bit more effectively. Now, this is a case study. This is my last slide of the deck, just to kind of illustrate if we deploy that kind of approach on multimodal data sets, what do we get out of it? So we conducted a vulnerability assessment on 8 major US hospitals. This is pre-COVID, by the way. So all of these results are pre-COVID, several years back. But what we can go ahead and do is identify specific devices, the vulnerabilities on them, the exploits that are targeting them, and then associate a severity score with that as well to produce more targeted ways of actually prioritizing devices for subsequent remediation. So that's the end of my talk. Happy to take questions, and the slides will also be available as well. I think we'll be doing questions after the next talk, if I understand.
Right. Yes.
Thank you, Ina.
Thanks, Sagar. So, Anita, you ready?
Sure. Let me share my screen. should point out SACAR's advisor, Dr. Chen, had some, he's like an evil genius. Their research is so cool. You guys got to look it up at some point, the dark web stuff. And that was a good lead in. My talk's going to be a little more generic. I'm not a user of OmniSOC data yet, or RSOC data yet, but I'm hoping to. But my talk will be a little scattershot, but bear with me. I'm going to talk about why it's important and how we can enable better realistic security research. So our goals, are really, so I am the co-PI of a big new test bed funded by NSF called Fabric. I didn't put the name here for whatever reason, but that's our logo, Fabric. And one of our goals is to think about how to do better experimentation for computer science in different verticals, AI, networking, security. Realistic experiments are really hard to do right now, even though there's a lot of different little test beds because of a lack of data. There's also a lack, no offense to the researchers, but there's a lack of really realistic threat modeling that goes on. And I'll go into why I think that is and how we can improve it. We want to democratize security research. And what do I mean by this? So I'm involved in efforts that are both in the academic circle, in the citizen science circle, and the hacker circle. And democratizing security research means by getting more people involved in it in different communities, the security research is a lot better. So having it not just in the vertical of like an InfoSec operator or an academic. And I think it's becoming increasingly, I think we're all seeing this, bridging, the research that's done in InfoSec, AI, networking, and systems research is really, really important. I stole this from somebody else's talk, but I love this. So what are some of the obstacles? So I hear this all the time now that I'm running a test bed, labeled data. So it's great to collect data. If it's not labeled and you're doing machine learning across it, it's really, really tough to use it. So I'm going to talk a little bit about how I think we can bridge this gap of like, here's a pile of data. Great, it's not labeled. I'm a researcher. I don't run a system. How the heck do I label it? OmniSOC, of course, doesn't get this. How do you efficiently share sensitive data sets? Right now, there's a lot of computational overhead for some of these things. There's not a great methodology and principles. Obviously, we're getting towards there. These varying institutional review boards for researchers, this is a problem that we need to solve. And I'll talk about this more. I've been at a couple universities. I'm sure many of you have noticed the policies about collecting and sharing data. Within OmniSOC, it's a little different because there's some agreements, but, were this to get larger, these widely varying policies that take years and years to craft, again, there needs to be more of a template as to how to do this. And finally, the lack of repositories, but again, OmniSOC's going in this direction. So some areas of opportunity. These are, talk about buzzword bingo. These are some buzzwords, but there's also some really good progress made, particularly because of COVID in things like privacy preserving data sharing and analytics. We see this a lot with medical companies and places that really do need to share patient data in a privacy preserving manner. There's a bunch of startups doing this and researchers doing it because that's a really, highly restrictive data. Multi-party computation, we're seeing snippets of this and sharing kind of network data. Likely that's overkill because of the overhead, but there's a methodology there. Seeing a lot more interest in federated learning across different devices. And I think this could be an area of opportunity as we have sensors deployed across the network for security. How can we learn across sensors in a privacy preserving manner? Finally, I think it's important that we really take steps in incorporating, so we're not just in this vertical of InfoSec research, of incorporating network measurement data. So there's a whole lot of networking data that's collected for DNS and kind of network type stuff, ASs. How does that incorporate it in? I don't know that we have a great grasp of this more. But by doing that, we can guide more realistic research in general. And I think, I've said this since I was at NSF, I think getting faculty or perhaps grad students in the SOC for a summer or a year, an internship, so that faculty who do security research are sitting there in the SOC, seeing how people actually operate for more than like a week, but for like several months is really important because then you see how unrealistic maybe some of the assumptions are. So this is just one example. This is a project I was not associated with. This is a project that was proposed by and funded for a year by CADA at UCSD. And this is about creating an open knowledge network. And I'm going to tell you why, this is a great effort, but didn't come to fruition. This is a great open effort. And the effort was to collect all this data and to share it. So collect routing information, addressing information, naming system information, if you can collect all this stuff, this can be really powerful data. This did not come to fruition. It wasn't funded. And look at the cool stuff they were going to do, like, being able to analyze and visualize, looking at suspicious patterns, looking at, if you look at concentrations of domains across registrars that are also ASs, you can do some interesting things. This, however, is, wasn't sold and isn't seen as like sexy type. It doesn't have the right buzzwords of like, it's going to help us defend the universe. But this is very, very important to research. And I think sometimes it's not included and it doesn't complement things like the OmniSOC type data because it's seen as maybe like complementary or outside the sphere of what's important for InfoSec. So I think, taking a step back and going back to these varying IRBs and kind of different campus views, mostly maybe people who aren't part of OmniSOC, if we look at extending it, kind of really reevaluating, is this data really sensitive when we think about sharing it? First and foremost, this has bubbled up a little bit. If you're not familiar with the Belmont principles, which are principles that came about to protect human subjects research, and a lot of security research falls under that. There was a Menlo report about a decade ago that really kind of talked about what do we need to do to do ethical security research. This needs to be updated. We have different systems. We're collecting different data, more data. We've really thought more about what this means for people for human rights. So working with researchers, I think, InfoSec people working with researchers and campuses to really update what human subjects research means for InfoSec. And I've seen varying degrees of this when different campuses collect different types of information. Of course, we're working on newer and improved sharing methods. I'll point out a few that, did well and didn't do well. So Impact was a DHS effort that has been sunsetted. And that was a way to share kind of security data that ended up not getting, funded in a sustainable manner because the overhead and the ability to get the different data sets the hurdles were just too vast. If you wanted to do it, you had to apply for it. And there were so many hurdles that researchers said, forget it, I'll either use synthetic data or I'll just get it myself for my own campus. So lowering those barriers is really important. On the flip side, this is great. I know Elastic is a sponsor for OmniSOC, but this Ember, if you're not familiar with it, Ember is a labeled data set of malware. They did over 1 million samples, and it's this labeled kind of benchmark data set that's free and open for researchers to use. That's a great effort because that's one kind of set of variables that is made open source for anybody. Just a couple pitches for things that are going on, maybe like not in, at universities. So I'm part of this DEF CON AI Village. And one of the things we're doing is there's people who are InfoSec operators, there's hardcore machine learning people, there's ethicists, and we're kind of right in the middle. So how do you bridge those two kind of sets of people to do something interesting, in particular to do security for AI systems and also AI for security, which are two different things, but they often are conflated. So a couple of things we're doing is this year is building a MITRE attack style framework for AI security. So if you think of all the vulnerabilities that come in, mainly the realistic ones are through things that places like OmniSOC are going to pick up. But how do those people understand talking to AI people who think about model poisoning and things that are very specific to AI? How do they talk between themselves? So building an attack style framework, also building an OWASP kind of top 20 for AI security. It's not perfect, but it gets the conversation going. Interesting to note, the first machine learning CVE vulnerability was only 2019. So again, this AI Village. This is where AI and InfoSec kind of intersect. And I feel like there's a lot more to be done in this area, thinking about everything from malware detection to red teaming and how do you red team and blue team AI as more AI systems are used in security. And there's a lot of thought leadership in this area, but no real kind of like, POC, GTFO in, which requires InfoSec people and show us a realistic threat model. This is to show you, and I'll wrap up in a couple slides, just to kind of show you Microsoft's attempt to look at, for AI security, how would you do a MITRE attack style framework? And I bring this up because I think this is a direction where a lot of these kind of SOC efforts are going. They're wrestling with, okay, maybe it's an AI vulnerability in our system. How do we categorize it? If it's, is it just a network attack? Is it a DOS attack? Is there something that we maybe peel back the onion and it's a data poisoning attack? So thinking about how the two sides talk is really important. So this was an attempt. Some final thoughts. I think for researchers, being specific on the data that they need to do security research. On the flip side, people who run SOCs and, like the OmniSOC who are sharing data, be specific on data that can be shared. I'm seeing this as we're building out Fabric is we're asking researchers, what do you need? And they're saying, well, what do you got? And so we're like in this cat and mouse game of like, we can collect everything. What do you need? Well, I'm not sure. As specific as you can be, that will be very helpful. I also think security people, I'll call InfoSec operators, can be a big influence on research. Start reading papers, email the authors, work with researchers like Sagar and Jay and others who are really open to listening to you on how to label data sets and get, they want the feedback, but sometimes it's hard because the conferences and workshops are very different in those communities. Finally, if you're interested, there's conferences like CAMLIS, which are, I forget what the acronym breaks out to now, but it's basically machine learning in InfoSec. And these are where kind of the two sides can talk to each other. So thank you for indulging me in my random thoughts.
Thanks, Anita, and thanks, everyone. I think some of the obstacles that you mentioned and pointed out, I think we are kind of going through them and trying to overcome, a lot of those obstacles, including, the data sharing agreements and differences in different institutions and how to bring multiple sources together. Also, the level of sensitivity of data. I feel like sometimes, we may end up being overprotective and ascribing, much higher sensitivity or potential problems to where they may not exist. Even when we're applying certain anonymization techniques already, and still, not like being super careful about sharing the data. So I think we can go into our discussion part. And so I had some questions that I posted, I shared with the panelists beforehand, and the questions, they are concerned, to continue this discussion on what is the benefit of sharing operational data. And I think, Anita, you made some really great points that we could maybe elaborate on, but also the sustainability models, because I think that's another important component. So maybe we can, Victor, if you could help and take a look if people have questions to the panelists.
Ina, can I comment on one of your questions? A couple of your questions?
Sure.
So this is also a follow-up with Anita's point. Very, very, thank you, Sagar and Anita. Really glad to hear your thoughts as well. So in terms of using and sharing operational data, because we went through that, I'll tell you that the number one thing is that there are a lot of modality, right? The modality, and it's not a steady state, right? And it's infinite, right? So think about this attributes. Right? Anita talked about label data. I understand, I agree with that, but I think that we in InfoSec, in cybersecurity SOC operation, we need to accept the fact that very, very, very little can be labeled. Even if you label it, it will not be editable. We need to start thinking about not supervised learning for cybersecurity, right? Absolutely, this one thing. But I'll give you the specific example that the challenge that we went through. Most of the time that when we work with OmniSOC and CACR, we are trying to solve this problem of managing, consuming infinitely streaming data. It's not just a speed, it's just continuously arriving, right? So this is the area big data community have tackled, but cybersecurity data community researchers have not, right? The data set is finite, right? Whether it's from 1999 to the most recent, this IDS from Czech, 2018, they're finite. It's a finite set of data. You get it using CCDC, all the impact data over there, mostly still finite, they're not infinite, right? How do you look at the model and data from a year ago, 2 years ago to today, right? How do you manage and store? Are you going to allow to go back? That is one area that none of the researchers are really tackling based on my knowledge. So I think that there's a lot of values in accessing and sharing and process operation, not just because they are real in the sense of the new up-to-date type of tech, but also the nature, the properties of that, the streaming infinitely coming in.
So Jay, are you saying it's like a storage challenge? Like you want to keep more than we're able to keep?
No, I don't think it's a storage problem. I think it's the way to process. So think about stock market, right? If you go to any stock market, you look at today's rising, right? You look at the week, you look at the month, you look at a year, 3 years, 6 years. There's a very nature way of looking at the average, right? Cybersecurity data, let's say I want to understand the attack behavior within this week versus the attack behavior a year ago. What is the meaning of aggregate of attack behavior between 2015 to 2020? There's no such notion about it, right? So that's what I was getting at, is that how do you aggregate averaging data that's non-numerical, right? And then how do you represent that notion that's evolving? We know it's evolving. And then you also talk about network measurement. So back in 2000, there was a time, before 2000, there was a time people started measuring the internet traffic and found Pareto distribution. Okay, so what are the steady state distribution, if there's any, describing attack behavior, attack data, right? Should we go to talk about, oh, the vulnerability or the exploit going to stay in your network for 300 days before it was discovered? But there's no statistical understanding of what kind of arrivals that's coming. So that's another aspect of it. So
but I think the math is not there yet. I think the math is not there yet, because I mean, you look at a lot of network data as time series, it's one dimensional.
Yes.
You talk about context switching between my network data, my systems data. I don't know that we have algorithms that are there yet.
We don't. That's yeah, agree. Absolutely.
So I think we have a question, and I'll just read it aloud. Have you thought about updating acceptable use or network use policies to include a statement that not only is there no expectation of privacy, but information may be used for research purposes? That may be something we should start adding. So I'm assuming that these kind of policies would apply to organizations.
If I were to comment just to kick off on this discussion, I'm not a policy person or lawyer. I do think that I agree with you, that we are maybe overprotective of the type of network data that we're talking about. I understand that. I think that in this kind of data, it's not necessarily personal information. It may be more vulnerability information that we're protecting. I think we're overprotecting in the following sense, right? The hackers, they won't care. They just, it's asymmetric warfare, right? Sagar probably is familiar with this term as well. It's asymmetric warfare. If we as researchers and practitioners are not trying to share what we know from each other, the hackers doesn't care. They will share. I think that this is something that we need to understand, that I'm not asking sharing everything, but some agreement and understanding at what level that we can share. Like, I'm hoping, for example, the one I presented, the type of characteristics is not specific to one vulnerability, right? There's no secret that Kerberos has vulnerabilities. This is not a secret there. You can just search for it, and you can find it. So maybe the certain level that we can share data, so that is just allowing IU, RIT, Purdue, any university or other organization to understand there are this kind of vulnerabilities, attack behavior that's going on. Not worrying about, because I as a researcher, I don't care about specific IP address, like being attacked in your network.
Right, and I think this is also an interesting question in the context of that point, Anita, that you made about democratizing cybersecurity. So right now, what we're doing, so first of all, we're developing an enclave, which is one level of protection, right? The data cannot get out. We're anonymizing certain sensitive parts. Again, another level of protection. We're also putting agreements and policies in place that add sort of trust as a third layer of protection, right? Where we're asking people to submit their credentials. And one of the main credentials is that you're coming from a research university. Or from a university. So the organization is behind the person. So if we think about democratizing cybersecurity, and you mentioned citizen science, and I thought it's really interesting to think about who can benefit from using the data and using it together in addressing some of the challenges. But that would mean, for example, for us, that would need to think differently in terms of who we plan to share the data with and how we vet people who we're providing access to for these types of data.
Yeah, I mean, you don't want to have a class of haves and have-nots where if you're at an R1 and you have a friendly CISO, you get great data. If you're anywhere else, you're on your own. So I think rethinking AUPs, and I think CIOs and CISOs have strong relationships with, whether it's EDUCAUSE or whatever, to really think hard about recrafting it. Maybe like, people are really against, DMCA violations, about getting, ratting people out for DMCA violations. So you say, here's the AUP. We're not going to go at you for copyright stuff, but we are going to use it for research. You can opt out. Maybe it's, being a little more, I think students are much more savvy about this. So maybe part of it is being just more transparent. I don't know.
So should we maybe talk a little bit about sustainability and what people think? Because that's another question that is very much on our radar and thinking. And so going back to the storage point, you said that it may not be about storage, but I would argue that it is about storage. We always say that storage is not an issue, but with big data and a lot of it becomes an issue, because it's not just the number of terabytes or zettabytes that you're storing, it's the maintenance. And we don't want to just have like cold storage that nobody can use. So it's the whole infrastructure, and storage is coupled with analytics and provisioning everything that enables access. And we've been trying to estimate the cost. And if you start thinking about these huge amounts of data that might be coming from OmniSOC and ResearchSOC, it becomes hard to sustain all these streaming data. So eventually, you have to either think about filtering or thinking about sustaining that type of infrastructure.
So I'll jump in first. That this is an issue with every type of science. People are perpetually wringing their hands, asking NSF for more money because there's just not enough storage. And I think for this particular research, for the physicists and all, maybe putting it in the cloud is better. I don't know that for this research, it's better to have our friends at Google storing it. So I don't know, Sagar, do you have something to add?
No, I don't have a solution for the problem. I have actually more stuff to add on to the problem as well, beyond just the raw data. In terms of thinking about sustainability of this, I think about it from the sustainability of a discipline. If we really think about the area that we're in, it's an emerging discipline, very exciting discipline, and so on. So the raw data is just one angle of it. But I think, just to quote a friend, Seeley Giles at Penn State University, inventor of CiteSeerX, a lot of the search in the search engine area. He had a great quote once saying that big data will generate more data. And so the data itself is the raw data that we see, but then the data that you saw in Jay's slides, the data that you will see in his demo, the data that is on this particular video, right? We may want to archive this video for future, that's all data that's being generated from the data itself. So thinking about sustainability is not just from the raw data point of view, but I think there's other angles to it as well in terms of what it generates in the academic life cycle, but also in the practitioner life cycle. I think the one key thing that kind of tying it back to the second question you had also asked, Ina, about sharing and reusing both data and code and research. I think one key thing that's really important as we're thinking about data sharing and model sharing and so on is that oftentimes as a researcher, and I see grad students on the call right now, you're asked to benchmark your model against the other prevailing benchmarks that exist out there. Well, you pull their code and you pull them into your environment. Guess what? It does not get near the performance as what it was in that other context, right? So as describing the model assumptions, describing the context in which it was deployed in, rather than, you know, it's just an afterthought, I need to get my paper out and so on, is that how do we actually build a culture around it in terms of having model sharing with assumptions built in, with the data sets clearly available or anonymized to an extent where the model's still accessible and so on. So I'm sorry, you know, I don't have a solution to this. In fact, I just poured more, you know, fuel in the fire on that one. But I think that sustainability, thinking about it from a holistic point of view, not just the data itself, but the data that gets generated as a result of the original data is also, I think, very important too.
So very quick comments on this sustainability. So one is that I do think the sustainable data needs to come from the purpose of this panel, right? Sharing operational data. The reason I say that is because over the years, from 1999 to today, there are actually a lot of cybersecurity data out there, mostly packet captures. But the problem is that it's all isolated instances where you can say it's outdated, you can say it is generated with a lot of different assumptions, it's not real, those things we know, but also there's no continuity, there's no context that's representing the evolving nature of cybersecurity. So in image processing, human faces, we don't change from 1 year to another year. I mean, eyes, nose, we are evolving, but not that fast. But cyber attack evolve a lot. So to have a sustainable, meaning that usable sustainable data, I think we need to have a process for operational data. Otherwise, it's just isolated instances where it's not going to sustain. You can have a lot of storage stored in instances, but they're not useful, in my opinion. Second thing is that I think that I mentioned this earlier. I think that needs to be some kind of a motivation for people to share, to analyze in a way that think about crowdsourcing. Right? Nowadays, that a lot of things that move very fast because a lot of people are interested. Not just me, Sagar, Anita are interested. Right? A lot of people are interested that things move forward. If I don't have time this month, someone else has a time this month. It's a crowdsourcing kind of society right now. So that's another element I think that can help for sustainability talk.
So we're getting close to 2 p.m. where we wanted to wrap up. Can I ask a quick question about the value of historical data in operational data? What do you all think? How far back is it important to keep operational data? Because operational data, it seems like, you know, it's the reality of it and the immediacy of it is really important. But what about the historical component? And like I said, how far back do you think we should be keeping it? Or can we just get rid of it, you know, once like 5-10 years have passed?
I think at least 5 years. I mean, you want to see how TTPs evolve, and that's, you're talking 5 years.
Mm-hmm.
It's my opinion for raw data.
I agree with Anita. I think that 5 year for cybersecurity type of data, I'm not sure about dark web. Sagar probably can understand that more. But I think for network vulnerability, operational, I think 5 years, we don't need to go back 20 years. I think if we spend effort and money more on the recent years, will be better. And furthermore, earlier was mentioned about malwares. Actually, some of my students and other people I think should be is looking at how malware evolve, right? How phishing attack evolve. So some kind of continuity on that kind of 5 year worth of data, I think is excellent.
Yeah, agreed on both other points, kind of thinking about other modalities of data outside of operational data. Say, for example, in the context of social media and so on, they have less velocity than, say, operational data that's coming continuously all the time. And so you have to go back, say, in the dark web context, going back 20, 25, 30 years sometimes, can get access to the sizes of data that would support some model training in certain situations. But I think it also supports that class of evolution, emerging, and so on in terms of cyclicality and seasonality of certain types of threats. So the further you could go back, the more you can actually pick up on those granular types of behaviors, irrespective of the data sources that are out there.
Mm-hmm. Thank you. Let's see if we have any more questions. I don't see.
Not at this moment. You know, you can jump into the demo if you folks are ready.
All right. So I would like to thank all the panelists for really insightful presentations and some interesting discussion that followed. And now I think we're ready to go into the demo.
Sure. And I don't know whether the audience can ask questions, but I will share screen to start with.
So I think we can do the same with the Whova app. If there are questions, we can monitor and people can post questions there.
So I believe you can see a dashboard, kind of. So I also, my students here are usually with me. I see him joining as well. Thank you. So this is a kind of visualization. What's behind the scene is already pre-processed the OmniSOC data we have collected during that time frame we talked about earlier. So in this particular set of demo, we have from, you can see August 17 to August 23 last year. And just to clarify what we are seeing here, right? So this is what we call a bubble chart. And bear in mind, this is a student academic prototype, not a commercial system. It's not going to be fancy like a QRadar, IBM QRadar, or things like that. All right. So the bubble chart, each bubble, each circle represents an attack model. And the X and Y axis are different characteristics that represent the attack. So here we can change the X and Y axis. We have 5 different characteristics, including how the attack maneuver in the network, inside, outside, internal, external, inbound, outbound, so on and so forth. Attack stage actually is modeled after the MITRE attack framework Anita mentioned earlier, but is intended to look for more intuitive, smaller categories that make sense, intuitive sense. ASN is autonomous system number, which I'll show you in a minute, and also the type of service being attacked and the speed. So for this particular demo, I'm going to start focusing on the attack stage and service. That combination usually is something of interest to the analysts based on what we have seen. So this is August 17 around noontime. I don't remember whether this is a CET or this is a Eastern time, what exactly time zone, but just keep that in mind. Now you see 1, 2, 3, 4, 5, 6, 7, 8, 9 models here. Is it 9? Maybe 10 models. Because some are very small. So if you look at some of this, essentially that if I go to look at this, so the size of the bubble, size of the circle represents the volume of alerts in the logarithmic scale with this content in that model. There's a very small one, tiny one on the left here, maybe not easy to see. It already contains very, very few alerts. While over here, this model is going to contain a lot of alerts. And some of you, depending on analysts, some analysts will say, okay, I love to see arbitrary co-execution, command control, credential access, but not caring about any vulnerability discovery. Those are just scanning. So what we can do is that I'm going to select a few different kind of attack stages of my interest so that I can filter out things that I'm not as interested. For example, there's 4. And you need to imagine that if the data is coming in streaming, then this will be run like updated, refresh every whatever, 5 minutes, 10 minutes, 15, 30 minutes, you can configure that. So you can see that gradually, you can see some small differences going on. We are moving forward a little bit in time. You'll see some models. If I fast forward a little bit, you'll see something a little bit faster, right? So you see a little bit change here, a little bit change here. So in reality, that you wouldn't see those bubbles moving so fast because you were looking backward, like maybe 6 hours or 12 hour or 24-hour time frame to look at what kind of collective behavior was seen, right? Now, maybe you'll notice, oh, so there's some command and control here, model number 6. This is command control going through some service called AMX-RMS, right? You may be seeing that, oh, here is a model number 7, it's the code execution, HTTP alt. And what exactly is that? So let's take a look at that. So we can say, let's focus on model number 7. So looking at model number 7, we will see some of the volumes, the attack features over time, right, from August 17 to August 19 for this model 7. You can say this particular model contains alerts that's telling people about, oh, it's switching between credential access and code execution. Keep in mind, this kind of like attack framework, right? A kill chain kind of idea. Between these two, and between HTTP and Kerberos. This is related to the model that we talked about earlier during the presentation. And it's switching doesn't mean that they will not have data before this 12 o'clock, 11 o'clock time frame or after. It's just that which one's more dominant and characterizing the attack. So this is very interesting. What's going on here? So if I'm an analyst, I look at, I saw this model maybe is at this time, August 17 at around 4:30 at that. Okay, that was a model that just started popping up, right? Very small volume. Let me show you the volume. The volume here is only at single digit. Remember, I talk about is hundreds of thousands of alerts. This model is only consists of single digit number of alerts during the time frame, during a very small time frame. So, hey, I see this popping up. It didn't exist before. Now it's popping up. I can pay attention to that. They take a deep dive. I can take a deeper dive by looking at what kind of alert distribution, what kind of features, what kind of things are in there. Oh, this is predominantly the HTTP at that point and IP manure, and the code execution with a little bit credential access. Like I said, is a flipping back and forth. Also interesting, I can see where does it come from? Autonomous system that come from, right? So as you go on, if I go back to this overview, if I keep moving forward on this, you can see that. And maybe actually I'll just go to August 19, see what I still have. Yes, I do. This model number 7, is model 7 still here? Model number 7, maybe I need to shift. So because our process, the model can disappear a little bit and come back up depending on whether it has a lot of things. I know that it is somewhere over here because on this map, when I go to that time frame, model number 7, I'll go back a little bit. What's interesting is that that particular arbitrary code execution through HTTP, Kerberos, that behavior, it was on August 19, around 4 o'clock time frame. It was from these regions. Okay? And then if you move forward, I just let it play a little bit. Right? Imagine that you were looking at it on August 19, between 4 to 5 o'clock. You'll see that it is moving. You see just that? I will go back a little bit. It was from this region, and then you move to this region. Okay? That's through the autonomous system number mapping that we have. Are they totally accurate? May not be because you can do IP spoofing, right? Go back. So that will be a model that if I'm an analyst, I look at the situation that can call my attention. I can look at something else. So for example, let's focus on command and control, right? So I want to go back in time a little bit, say August 18. So I have this command and control because this is something that we want to watch out for. We don't want to see any command and control. Again, the data that we got is to recover alerts that can be due to real malicious activity, but it can also due to the sensor is so sensitive and picking up a lot of false positives. It could be either way. But here I'm looking at, so there are 2 kinds of services on the y-axis that sees command and control type of attack, right? If you move forward, you'll see, there are more or less different kind of services. Sometimes WSMan. Remember command and control, I show you an example that different services that is suffering command and control type of attack. So this is showing you that kind of situation. And sometimes you have more, sometimes you have less. So let's look at this 4, for example, model 31, 34, 6, and 0. Let's just do 31. I think the other one is 34, because those are small. Typically what we have found interesting is that the small ones are the ones that we typically like to pay attention to. So if you compare these cases, they are all command and control. 34 only show up in a small period of time, spending around 5-6 hour time frame. And while model number 31 is actually ranging between WS discovery, these other services as well, multiple services, while the model 34 is just based on that particular service. All the services mapped directly from the port numbers. Right? So you can look at some of this situation. Is this what analysts is expecting? Right? The point about this system is really bring the attention to a collection of the alerts that may be indicative of one kind of attack behavior or mixture of related similar attack behaviors, not just say it's individual alerts, right? And it is not alert correlation where a lot of people out there has proposed that require, okay, I build alert correlation map, attack graph, I will map or match the alerts onto attack graph. Here we use totally, there's no expertise behind this, putting this together, okay? So I'm going to pause a little bit. It's 2:20, halfway through our demo time. I want to open up the floor for any people who want me to try something, right? I can get rid of any of this and we'll go back in time a little bit or forwarding time. And you can see a variety of different models here. If anyone want to take a look at any particular attack model, we can dive in deep into those models. Anyone? So while we're waiting for people who maybe comment on things that you want to take a look. So with this demo means that if I'm in a classroom, I will welcome anyone to say, hey, click on that node, show me what is going on. So for example, this model 43, go ahead, Hagar.
Yeah, I just have a quick question, Jay. I think just while we're waiting for some other questions from the audience is that, you know, it's the unique characteristics of the data that you're operating on, the speed, the velocity, the characteristics of the data and so on. Can you talk a little bit about the technology stack that you use to develop this particular system? So in terms of backend, the web technologies and so on, because I think one challenge that folks may run into in terms of developing their own systems, and if it's proprietary, you're not able to answer, totally understand, but one challenge that people run into is choosing the appropriate technology stack such that they can deal with the data characteristics that are coming in. So can you comment on that a little bit?
So hopefully I answer your question correctly. So everything is developed in Java, Python. So nothing special is our algorithm, and we have the most latest paper that is under review right now, but we're going to put it on archive for people to see. Essentially, the algorithm is unsupervised continual learning system using some entropy measures, right, to make it fast. So this is not supervised learning. We're not building an AI model. There's no label associated with it. The idea is to continuously update the model, maintain the model in the order of like 20. If that's what you're asking, the Java, Python, the front end is we just recently developed.
Are you using a relational database or are you using a different type of database?
I can talk a little bit more about that. So the algorithm itself, which Dr. Yang and the research team developed, is pretty much in Java. And the rest of the application, we're utilizing a mix of Python and Docker. And the reason we're using Docker is because it's much easier to be able to just go on a server, download the GitHub repo and get the Docker container up and running. So it doesn't matter which organization you're going to, where you are, all they need is, here's a server, you can get up and running on it kind of scenario. In terms of the database, currently we are only using a relational database, PostgreSQL. So all of our alert data is stored on there, all of the output from the assert algorithm is stored on there, and that's what the visualization piece of it uses as well. So that just kind of runs on its own Docker container. In terms of the front end, I'm using Dash and Plotly, so it's a very popular front end and written Python. It uses React under the hood, so everything flows really well together. And I think those are all the big
and the
pieces.
IO are JSON. IO are basically in JSON format. So nothing,
Excellent, thank you.
And while you were talking, there was a comment or question or maybe a request. Someone said they would like to see more about data exfiltration. What can you tell from it?
Right, so there are a variety of number of data exfiltration. Let's say go back in time and we move forward to see how it looks like. So let's say data exfiltration. Okay, and at August 18, 11:30, there's one model that's data exfiltration. Within that model, if I want to select it, this is model number 2. You will see that actually it's mostly Telnet and EP map, right, around the time frame. And I will just continue to move forward. You may see other models that, Now you see two models. One is here. It's still the model 0, the other model number 2. So if I move forward faster, a little bit faster. So this is, I think, the same thing as before. So you can see that most of data actually, oh, now you have a different kind of service here, WPL. That's the same model, but it's something else dominates. You can see that, I'm going to include that model 0. So model 0, you can see is the red color here. It's more, it changes based on whether you, the data exfiltration is categorizing that model or is it some other categorizing. So that model look at continuously different alerts entering the model and leaving the model. So it may change over time. So model 0 does include a lot of different things over there. Let's move forward to maybe August 20th. And it looks like that this EP map is a very persistent service that is being used for data exfiltration. Again, it may be malicious, may not be malicious. EP map, if you can look it up for me on port numbers there, it'd be helpful. So all the way to August 20, that will be the primary dominating model on the EP map continuously with data exfiltration. The tail map is the same thing, is shifted between these two.
EP map is port 135.
135. So for those in the SOC operation, you might know more than I do on what that exactly indicates. When we access this question related to this panel, we do not have the real raw data. It's anonymized alerts for us. We know the port number, but we don't know the details of actual servers, IP address, none of that. We do not know that. So we know exactly what went on in this node. So it looks like this data extraction mostly is that particular one. The other things that's going on, but mostly this dominates the data exfiltration in the data that we processed. Love to hear the feedback from the person who asked about the question, if he or she has any comments about this EP map data exfiltration.
I think we have one more question,
Sure.
Jay.
Yep.
For assert, are you capturing any filters choices that the analyst is using to inform an insightful discovery? In other words, do you know what information was used by the analyst to make a conclusion, perhaps save the filters used throughout the investigation?
So as far as we know that this is going to be only part of their analysis. So they do a lot of corroboration of evidences, not just based on recovered alerts. They will look at Zig data, they look at some server logs, they look at some threat intelligence, and they probably know more about the actual servers in the network to make a determination whether the system was actually compromised or not. So this is only a piece of the puzzle for them. And we do not intend to replace people making conclusion or decision there. So I'm not sure that I answered the question. Did I answer the question?
Let's see if we have any follow-ups. I marked it as answered on Hoover, but
So the main purpose of assert is really to assist, to bring analysts' attention to models that the type of attack behavior they're more into, like data exfiltration, right? So if data exfiltration is the only thing, not the only thing, but one of the few things the analyst is interested, then you can use this kind of actually the other one I can do is, for example, if I'm interested in not that just data exfiltration, but SSH, right? So I want to see what happened with SSH throughout the days. So again, you need to imagine this is continuous running, right? You can look at, this doesn't. So you can continue to look at SSH and see how that looks like continuously.
So what's happening there is, just as a note, sometimes SSH is not as part of a model, in which case it won't be filtered out because it's not there.
Yeah. So I do remember when I was looking at this, there was SSH was persistently doing some credential access through SSH. And if you want to monitor a different kind of SSH, that'll be good. Let me look at 32. It was not good yet.
So I think, yeah, I think it does answer the question. I'm just looking at it.
Great, excellent. I think it's a 2:21. I want to be conscientious about the time that Ron has need to close up.
Right.
Yep.
Yeah.
So final note, thank you for being here to see our demo. We love your comments, critique. Do not hesitate to email me, j.yin@rit.edu. j.yin@rit.edu. If you have any critique, anything that we love to hear your thoughts, I think that's how we can improve what the system can do for you instead of just blinded in our ivory tower doing our research. Thank you.
Right, and I would like to thank our panelists again and mention again that this is a continued work. We're continuing to working on the Enclave and thinking about how to share data, and both from the technical and the policy side. So I would encourage people who are interested in these topics to reach out, to either the panelists or us at the ResearchSOC. Thank you so much. I think we can conclude this session and then, take a few minutes break and then move into the other session with the concluding remarks.